To problem number 19 of the MIT Integration Pre-Qualifying Exam 2014, which is the definite integral from x equals to 0 to x equals to 1 over root 3 of the square root of x plus the square root of x squared plus 1. And those are nested square root signs. So let's see how we may be able to solve these interesting problems. But yeah, let's see. So from x equals to 0 to 1 over root 3 square root of x plus square root of x plus 1. This is our problem. Since this entire integrand looks very intimidating, let's try substitution. And we say let y be equal to square root of x plus square root of x squared plus 1. And so y squared is equals to x plus square root of x squared plus 1, y squared minus 1 minus x equals square root of x squared plus 1. And so if we square both sides, we get y to the 4 minus 2xy squared plus x squared equals to x squared plus 1. And the x squareds cancel each other. And so we get y to the 4 minus 2xy to the 2 equals to 1. And this is an interesting place to stop, because one, we can say 4y to the 3 dy dx minus 2x times 2y dy dx minus 2y squared equals to 0. So 4y cubed minus 4xy dy dx equals to 2y squared. And so for y, we have y squared minus x dy dx equals to 2y squared. So y squared minus x over y dy equals to dx, which is now we forgot the 2 here, so we can put the 2 there. So we have 2y minus x over y dy is dx. Now we also need to figure out what x is, and since we had seen that y to the 4 minus 2xy squared equals to 1, we can say y to the 4 minus 1 equals to 2x squared, and y minus 1 over 2y squared equals to x, meaning that a half of y squared minus 1 over y squared is equals to x. Very important part as well. So we have two relationships. One is 2y x over y dy is equals to dx, and then half of y squared minus 1 over y squared equals to x. So we want to substitute this in here. So we have 2y so we have 2y, this and that, y squared minus okay and so which is 2y minus half of y plus so this becomes half y, so we have 2 half y plus half of 1 over y cubed. Okay, now next thing is, let's look at the limits. Since y equals to, when x equals to 0, y equals to, this becomes 0, 0, square root of 1, square root of 1, so we can 1. When x equals to 1 over root 3, y equals to this is 1 over root 3 plus 2 over root 3, which becomes 3 over root 3, so this becomes 3 to the power a quarter. Okay, so this cancel, and so our problem now equals to 1 to 3 to the power quarter. This becomes y, and the x is y plus okay, which is it becomes a third y cubed minus y 1 2 3 to the power quarter. Okay, so let's keep going. So we've come to a point where we have a third y it becomes as 1 over minus a third minus 1, because when y is 1, this becomes a third, and this becomes 1. So this becomes times 3, okay, minus so let's do that, minus negative 2 over 3. Interestingly, if we pull this a third out, we have 3 over 3 quarters, and this becomes 3 . So as we can see here, 1 minus a quarter here, 1 minus a quarter. So maybe we can expand that. 3, 1 minus a quarter here, plus 2 over 3. And this becomes 0. So this becomes 2 over 3. And so our integral from 0 to 1 over root 3 of the square root of x plus the square root of x squared plus 1 is equals to 2 over 3. And that, ladies and gentlemen, is our answer.